The McGinty equation is, well, a novel mathematical framework in theoretical physics designed to unify quantum mechanics, field theory, and gravity by incorporating principles of fractal geometry alongside traditional quantum concepts. This equation addresses one of the long-standing challenges in physics, reconciling the behaviors described by quantum theory at microscopic scales with those of gravity and space-time curvature at macroscopic or cosmic scales. The standard form of the McGinty equation is as follows. Psi of x and t equals psi qft of x and t plus psi fractal of x and t d mqs. Here psi of xt is the overall wave function describing the system. Psi sub qft of xt represents the quantum field theory solution, which describes particles as excitations in an underlying field. Psi sub fractal of xt d mqss is a term accounting for the contribution from fractal geometry, with parameters d for fractal dimension, m for mass, q for charge, and s for spin or scale. Key features and innovations include the integration of the Schrödinger equation and quantum field theory concepts, with new fractal parameters to capture the self-similar scale-invariant structure in quantum systems and possibly space-time itself. The equation proposes that the often mysterious or probabilistic behavior of quantum systems may actually arise from our limited understanding of the underlying fractal geometries of space-time and quantum fields. This approach allows the equation to potentially predict and describe phenomena that previously resisted explanation, such as the stability of hypothetical micro-wormholes or certain cosmological anomalies attributed to dark matter or dark energy. The fractal correction term enables the modeling of quantum gravitational effects, helping bridge a gap where gravity has been, rather challenging to integrate into quantum frameworks. Now, when we examine the mathematical properties, the McGinty equation is, well, constructed to preserve core principles of quantum mechanics such as unitarity, which of course is the conservation of probability, and other conservation laws. Mathematical scrutiny suggests that its modifications still produce unitary time evolution, which frankly is a critical requirement for any physically meaningful theory. It's derived using established mathematical tools, including the convolution theorem, Laplace transforms, and yes, integral calculus. So, the equation, it models particles as manifestations of quantum field excitations shaped by fractal spacetime, rather than as point-like objects. It actually frames gravity not as a fundamental force, but as an emergent property arising from the structure of spacetime as influenced by fractal field interactions. Some interpretations suggest it could perhaps enable the theoretical creation of stable micro-wormholes or even so-called space-folding technologies, although honestly these remain speculative and unproven. The McGinty equation is considered a generalization or extension of quantum mechanics, not a replacement, and is subject to ongoing scrutiny and experimental validation within the scientific community. While promising, it is still a topic of active research, and its ultimate acceptance will depend on its ability to make novel, testable predictions and withstand empirical testing. In summary, the McGinty equation is best understood as an ambitious attempt to unify the fundamental forces and scales of physics by combining the strengths of quantum field theory, general relativity, and fractal mathematics into a single cohesive framework.